Hi, welcome to the talk QtBridge plugins in depth. My name is Vikas and I'm working with the Qt company since 2016 as senior software engineer. I worked in Android and iOS support in Qt Creator, and then I moved to Qt Design Studio where I implemented Asset Importer plugin and QtBridge plugins for Adobe XD, Photoshop, Sketch, and Figma. Asset Importer plugin is the plugin which takes the output generated from these QtBridge plugins and generate QML. I will be joined with my colleague Alexei.
Hi, my name is Alexei. I'm senior software engineer at the Qt company. I'm involved in the development of Qt Design Studio since 2019. I'm responsible for maintenance of QtBridge for Figma, as well as other different areas in Qt Design Studio development.
In today's talk, we'll talk about what QtBridge plugins are and how you can write your own QtBridge plugin for any design tool so that you can integrate it with the Qt Design Studio workflow. We will talk about the architecture, how these plugins talk with Qt Design Studio, and then we'll talk about the metadata, the information that these plugins are supposed to spit out, which QDS can understand and then generate QML from it. And Alexei will actually talk about the Figma plugin and what are the challenges and what are the pitfalls one should expect when we are writing such kind of plugins, and probably some of the ideas how to mitigate these problems. Also, we'll write a brand new plugin, a very simple one, as a use case to demonstrate how you can write your own QtBridge plugin and how it works with the Qt Design Studio. For any questions or queries, please type your questions in your chat box during our presentation, or try to reach us from normal channels of email, and we'll try to resolve the queries as best we can do. So what are QtBridge plugins? So the idea behind QtBridge plugin was very simple, that we will have a design tool where you can slice your assets, we'll generate the assets, and in Qt Design Studio, we'll bring it to the project, and this will help the developer and designers to generate the UI faster. But soon we realized that we can also write some wrapper QML around it. We try to do that with default settings and everything, and we realized that there is not usually one-to-one mapping directly with design tools and QML. So we needed a plugin running inside this design tool where you can annotate your layers and add this extra information which will help you to generate better QML on the Qt Design Studio side. So we took this proof of concept with Photoshop plugin, and we implemented one plugin for it where we can decide, okay, I want this layer, I don't want this layer, I want this layer to be rendered as image, or just keep it text and all that stuff. That was our first plugin, and in today's time we have plugin for Photoshop, we have plugin for Adobe XD, Figma, and Sketch, and all of them spit out the same data, this QtBridge archive, and using this archive we can generate QML inside the plugin. And soon you will see what this archive is and how to write this metadata, what are the properties that one must write, and how Qt Design Studio interpret those properties and generate QML. And we will also talk you some advanced stuff where those extra properties goes, and how to generate assets, how multiple scale factors can be generated. So let's look at the architecture. So the architecture, like I said, it's very simple. You have a plugin in that application, the design tool, and using the plugin, you generate this archive. This archive is basically a bunch of assets and this JSON document that we call the metadata document. And inside this JSON, we write the whole DOM and some extra annotation that designer added while using the design tool. And everything is packed under this neat archive. So you bring this archive to your Design Studio, and you can generate the QML for the current QML project you have opened in the Qt Design Studio. So we will give a short a short run with Adobe XD, and let's see how this whole workflow works. And using that same ideas, we will try to implement a new plugin as well. So let's open Adobe XD. Here you can see a small example. So in this example, I have some text layers, I have some rectangles, I have grouped them, and using the plugin, QtBridge plugin for Adobe XD, I have annotated like this is a component, the root level item, and if I go inside the tree, you can see there are some child items, some text item. Text by default is always a child, but this text I want it to be rendered as an image because it's a logo. So you can do that as well. So let's give it a shot and export this project and see what happens. So here we export. This is the export dialog. You see, you have some logs like which renditions are created, which layers we went over. So this is QDesign Studio. Open a project, and on the assets panel, go to design mode first, and you will see asset panel. You can click this plus button, or there's a small plus button over here to add assets, and this will launch a dialog. And here you select the archive that you exported from XD. This is asset import dialog. You have some options to affect the generated QML, like rounded coordinates and just generate QML and all that stuff. Here we also have some log. Any warnings, any errors will be reported here. You see all the assets are added to the assets panel, and let's go to edit and open our generated QML. So this is the component that's generated, and you see all those layers, all the positioning, it's right there. Child layers are child layers, and the logo is also rendered and not text anymore. So this is a nice QML generated from it. So yes, so we are using anchors by default. The QtBridge metadata format. So this is the JSON format which the QtBridge plugins must export so that QDS can generate QML from the design that you have exported. So this is a very simple format. You have three main sections in the QtBridge metadata file that you spit out, and these sections are plugin info, document info, and artboards. Plugin info is just an object which tells you about the plugin that has generated this file. So let's look at the metadata format from a bird's eye view. So you have this plugin info object where you tell about, okay, what is the name of my plugin, the metadata version that I'm exporting, which version of extension I'm using. Then the important part is this artboards. This artboard contains all the components, the QML files that will be generated. Each component is just a layer in the design tool. So we'll go over the objects one by one. So plugin info object has some properties, application IDs. When you are implementing a new QtBridge plugin, you should always use the value generic. Otherwise, other options are like for Photoshop, XD, and Sketch, where we has some special processing that we have to do. But for normal new development, generic should work fine. Then you have application name. This is used just for logging, so no real impact on the generated QML actually. The application version also, which application version you were using. So this help us log the information and figure out the bugs and shortcomings later on. This is quite helpful actually. Then you have the extension version. This is important value that you must include in your metadata, and this tells that which version of application that you use, because over the time the APIs change, and sometimes the data related to an object is a little bit different. So this helps to narrow down how to process those values. The metadata version, metadata version is 1.1. This is what you should use always, and if something changes, then of course we'll notify through our documentation or in the blog. For your information, all this values, all these keys. This whole document will be published as a blog where you can go and refer and use these correctly. So next value is asset name scheme and coordinate system scheme. So these are two very important properties. The asset name scheme is primarily how your assets will be named when these assets are added to your project. So currently it supports two values, UUIDs, and I think the other value is default. The UUID asset name schemes means that each layer with which an asset is associated will have a unique identifier, and the asset name is also named on that unique identifier. And when we import this layer and generate QML out of it, we use the QML ID to name the asset. So why this is done? Because in design tools, a lot of layers share the same name, like background or label. So when you generate assets from it and you try to name the assets on the layer names, then you have this name conflicts. So a unique identifier in this case is used so that generation becomes easy, and we rename the assets when we bring them in the Qt Design Studio and add it to the project. So the next item is the next property is coordinate system scheme. So coordinate system scheme basically tells that the items, the layers inside your JSON document, they have this coordinates, and which scheme does it follow? Is it global or local? In global, it will always be in the scenes coordinate system, and will translate to the local coordinate system when we import stuff. And if your coordinates are already in local, then use the local coordinate system scheme over here. So these values actually help us to figure out how to place your layers and how to place your assets inside the generated QML. You might also want to know about the color formats, because color value is used quite extensively in the JSON in this metadata document. For example, font colors and colors, extra QML properties that you add in the layer object, which we will go through later on. So the color value is always in ARGB format and hexadecimal values. So this is what you should use when you are writing your color values in this JSON document. So that's it about the plugin info object. This is a brief representation of how a component is. Like, you have some XY properties, some metadata, asset data, everything. So let's go over these properties. So this is primarily a layer object. So layer object have some properties like name. What is the name of the layer? This is used in logging. Layer index. This is very important, and this decides the stacking order of the items generated in QML. Then you have X, Y, width, height. And these are the properties, just to position the item. And the very important property is the metadata. The metadata has all the QML stuff inside it. So extra information about this layer object. So let's go through this metadata object. So this is also a pictorial representation how this layer object will look like. You see all the properties, and this metadata is where your QML ID, your export type, and opacity, all these values goes. So we'll go through these properties one by one to understand how this affects the generation of the QML. So metadata object have some properties. The most important property is the export type. We'll go through this in a minute, because it needs a special separate slide to explain this. Then we have QML ID. QML ID is the ID that you use in the QML items. We generate it from the layer name usually, but we make sure that it's still a QML valid QML ID, like does not start with a capital letter, and only numbers and letters are allowed, underscores allowed, all that stuff. Then you have this UUID. Now UUID is very important. Each layer in your project should have a unique identifier. Why we need this? First use case will be to avoid the name clashes in the assets. But there is one more use case, and this use case is when somebody generated a QML, then the developer is working on it, and developer have some QML programming, add some mouse areas, add some properties. Now designer reworked the item and you re-export it. When the user and this unique identifiers are same, then we can figure out this is the item which is in the code and with the item that came from again from the import, and then we can merge the changes that the developer has done. We don't rely on QML IDs because they often change. Developers change the QML ID, adding some more descriptive names, so we cannot rely on QML IDs directly. So that's why we have this unique identifier, and each layer should have it unique in your with respect to your project. So the next property is asset data. Asset data is basically the asset associated with your layer. So whenever a layer has an asset data property, this means that we'll generate an image item from it, and asset data has the exported asset URL. So we also go through this property a little bit in detail in next slides. So then we have some extra properties, some advanced stuff that we think it's not a good idea to cover in this talk, but we'll try to give you the important ones. For example, extra import is basically if you want to add import statements to the component that will be generated from this QML. So let's say you have a component called button. Inside this button you have a few more layers. So any of this layer can have this extra import statements, and whenever this happens, all these import statements are added to its parent component. Then you can also have some extra QML properties. Let's say you have an image object image layer with an asset, and you want to add some opacity just in QML, or you want to add some custom property that comes from a model or all the stuff, or even you can add some new properties. The syntax is same as you use in QML, and add your QML properties to this text area, and these will also be applied to your generated QML. Internal reference, external reference, these properties are renamed to now type name and type UIDs. This is what you should use. Type name is when you assign a type name to a layer, then the QML generated will have this type. For example, I want this layer to be my custom item. Then you write this my custom item in type name, and the generated QML will have that type. Type UUID is also a very important concept, and this concept comes into play when you are using components. So these design tools like Adobe XD, Figma, Sketch, they have this idea of components. So you can create a component, let's say a button, and then you can reuse this in your design all over the place, and they have the same rendering that you have generated in your component, and any change that you apply to this component will be applied to all the instances of this component that you used in your design. And type UUID is very important. Why? Because whenever you use an instance, your JSON should have this property type UUID, and it should have the value of the UUID of the component of which this layer instance is. So if you have this button component and you are using these instances of this button component, when you export, make sure to create this layer item for these instances and add type UUID, and type UUID will have the value, the UUID, the unique identifier of the component. If this is the case, when you generate the QML, it will see, okay, there is a type UUID associated with this layer. So this layer is just an instance, and instance is this component which will be generated, or which is already generated, and it can figure out what's the type name of that generated component, and it will apply to all of those instances. So the next property is anchors. Usually you have this X, Y, width, height properties associated with each layer, but you can also specify anchors. This is just a comma separated string value of left, right, bottom, or top, and whenever these anchors are present, then we don't apply the X, Y properties directly. Instead, we translate them to anchors. So X properties will be translated to margins and bindings to its parent, but the anchoring is always done to its parent. So far we don't have the capability or the feature to anchor to any object. So anchoring is always done to its parent layer, so please keep this in mind. So export type property basically define how a layer is exported and what kind of a QML we have to generate. What is the relationship of this QML to its parent? So there are 4 values: component, child, merged, and skipped. So the component is very simple. This layer will create a separate QML file. So inside the artboard array, you have these components. So a component can occur anywhere in the hierarchy of a layer, and whenever we say, okay, there is a child layer and this is exported as a component, what we will do is we'll create a component from that layer and insert an instance wherever this child layer was in the hierarchy. And if it's the topmost layer, then of course a QML will be generated. So that's the component type. This layer is basically child of its parent. Skipped is just ignore this selected layer, and the important one is the merged property. What does merged means? See, there is when designers design an artifact in a design tool, they normally don't use one layer. So they use 3-4 layers to create an artifact, and it doesn't mean that all these 3-4 layers should create one separate QML items when you are generating QML from it. So when you say a layer is merged, so what happens is the asset of that layer merges to the asset of its parent, and none of the properties from this layer will be exported or will be part of the QML. So let's say you have to create a star, you will use 2 or 3 triangles, and the bottom triangles are just merged to the parent layer. So this is how you create composite items, assets, but the QML generated is just one QML, not like 3-4 items. So asset data object is basically composed of properties like asset path, asset bounds, additional assets, and reference asset. Asset path, as the name explains, is just the path of the asset which is associated with this layer. So this is pretty simple. Asset bounds are primarily the position of the asset with respect to its parent. So an image layer can have an asset but not filling the whole layer. It can be placed anywhere on that layer. Then you have additional assets. So the QtBridge plugins have the possibility to export assets in multiple formats as well as in multiple scales. So you can write your additional assets generated for this layer as an array in string array inside this property, and QDesign Studio will import them, assign proper naming, and these additional assets will be imported as well. So the last property in this object is the reference asset. So this reference asset usually is not part of the generated UI, but this is usually for the reference for developers to see how this component basically look like. So usually in this reference asset you uh, you know dump all the layers, you render all the layers including text, everything. So it's a just top level asset for that component, which the developer can look at and see how the things are created, because the text is not rendered equally across these tools and Qt itself. So the, there are some differences. So this is a good idea, developers can have a look at that. So we already talked about the advanced properties, like extra import, QML properties, type name, type UIDs, anchors. So there is one more property that was not part of the previous slide, that's called the main component. So I think this was the part of 3.6 release in Qt Design Studio. So in 3.6, what you can do is, like, when you import some components. Qt Design Studio creates some components and that's it. Then you have to write some code to show at least one of these components when you launch the application. So what main component does, it's just a Boolean value associated with any component within this metadata file. And wherever we say, okay, this is the main component, we Qt Design Studio you know makes this component as the launch component. So you don't have to write any extra code to see one of your components when you press the run button in Qt Design Studio. So if you have a main component that's exported from your design tool, the Qt Design Studio will make sure this component is the component which is shown the first time when you launch the project. Now Alexei will explain you how we use this metadata properties in Figma plugin, what were the challenges and pitfalls when we implemented the Figma plugin. Over to you, Alexei.
Thanks, Vikas. Hi. So, I'm going to give a brief introduction into how we have implemented our Figma Bridge plugin. Figma provides developers with multiple types of APIs for all kinds of integrations. The most importantly, there is plugin API, and then there is REST API. Also, they have widget-specific and FigJam-specific interfaces. We're using only plugin API. It has mostly everything what we need and is perfect for our use case of so-called single-player use case or single-player expert. Plugin code is written in TypeScript, and we're using React with styled components for UI of the plugin. UI itself is nothing complex, but it does the job. The most important things start to happen when user clicks expert button, so let's go through it now. First, we do a little preparation. Plugin reads the project file, iterates through all project pages. On each page, plugin is interested only in nodes that are direct children of those pages. There, it identifies 3 types of entities. Simple frames, they will turn into regular QML files. Components, they will turn into reusable QML objects. And component sets, they will turn into reusable multi-state QML objects. Only after that does actual metadata assembly start. Identified nodes passed into recursive algorithms where the nodes, their children, and their properties are being processed. During that process, plugin also identifies nodes that could not be properly exported and instead exports them as images. And it checks for remotes, instances of remote components from Figma team libraries. We will talk about it slightly later. There is also plugin data. Plugin data is something that user sets in plugin UI, and it includes plugin settings, things like image asset settings. It also includes custom item IDs or property overrides. It also includes export as field. User could, for example, explicitly set some items to be skipped during the export, or set multiple items to be merged into a singular image asset. We're not blindly exporting all properties. Things do not work one-to-one between different tools, so we have our own export rules, our own heuristics. We know which Figma node types have better compatibility with QML and which do not. And so it leads us to node processing. Now, plugin checks plugin data, Should this node be skipped or merged with its siblings? And which item ID should it write into metadata? Then it checks node types. As I mentioned, we have custom expert rules for specific types, for example, for vector nodes. Depending on user settings, plugin will export all vectors as rasterized image assets or will attempt to generate dynamic QML objects with vector paths. This kind of object could be easily recolored or rescaled in QML later. Not all properties and node types are easily translatable between Figma and QML and QtQuick. All of them have hugely different implementations. During the export, plugin always checks if there are incompatible properties and fallbacks to exporting something as image asset instead. We're changing it step by step. We introduce support for more types, so hopefully we will have to fall back to rasterizing less and less items. Most recently, we improved support for such Figma types as ellipse, arc, and pi. We came up with idea of using Studio Components arc item for them. So now, instead of rasterizing all arcs and gauges, we attempt to generate dynamic animatable QML item. And it also brings us to remotes that I mentioned earlier. Figma has the concept of team libraries. Publish projects with reusable items, such as components and component sets. Those items are not defined within the user's current project, but current project still uses them. Previously, plugin was ignoring them. It was detaching every remote instance and then it was exporting metadata. That was leading to generation of similar QML items, similar QML lines. Obviously, it works, but it's damaging to the idea of componentization that we're trying to reach and to improve upon. So nowadays, plugin remembers also called master components of remote instances that it encounters and includes their export into main export process. It should significantly help users with already existing design systems. So, when you're using or especially developing a exporter plugin, whenever it is Figma specific or for any other design tool, there are lots of things to keep in mind. Here are some of them. First and foremost is direct translation one-to-one between different tools and different frameworks is a very hacky process. There are different implementations of similarly looking items, different properties, they have different interfaces. Finding similarities and adjusting the differences is a particularly important part of this kind of plugin development. Text handling and asset handling is direct and the simplest example of this point. Vic has previously had problems handling text properties from Photoshop, and now I have different issues with aligning Figma text and font properties with QtQuick. Image asset exports done differently by many tools with different options as well. And the best export result would certainly be done by UI instruments of the original tool, and you will probably hack around to create something similar. Design tools do not expose all properties to the user whenever we're talking about UI or API. One of the examples in Figma, user can flip or mirror any item in their project, and Figma UI will not indicate the property change to the user in any way. The node itself does not have flip property in API as well. Instead, it has transformation matrix that stores all transformations, applies to that node, and you will have to decompose the matrix first before being able to say that this item is flipped and it needs to be placed differently. If your expert plugin or any other tool you're working on is not handling flipped items properly, they will be misplaced in the resulting import. Some projects, especially those that are imported to the current design tool from any other design tool or had some sort of automatically generated parts, might contain impossible properties that even current design tool cannot handle. For example, users started their project in Sketch and eventually moved to Figma. They used some importer that helped them with transitioning between tools, and this is, by the way, exactly what we are doing here as well. But plugins and bridges will eventually have to work with the result of this generation. You should expect probably anything. It could be items with broken transformations, it could be strange mix of stroke properties, or just crazy vector network. There are lots of inspection plugins available for all design tools out there. They provide you with information about item node internal properties. It's not just data that you see in tool UI, it also includes some properties exposed to plugin APIs. For Figma, it could be Node Inspector plugin or just Inspector. Those plugins are great for getting familiar with API and for troubleshooting of your really misbehaving or strange items. Inspectors are just simply great instruments for power users and those design tools. They can help a lot, they're really your friends, but if they are not properly maintained by their developers, they might be behind some API changes and will not work as expected, so you will have to keep it in mind.
Let's try to implement a demo QtBridge plugin. For this, we'll use the application, the design tool Zeppelin. We have to have some plugin infrastructure to write our plugin. Different design tools have different way of implementing plugin, different technology stack. Primarily, we have to go through the DOM of the project, go through each layer and try to make sense which layer it is and what we want to do with this layer and generate metadata for this and export this whole DOM into this JSON document. Zeppelin has nice documentation about how to write extensions for their application. You can go through this and primarily there is a tool called SEM. You can use this tool to create a basic facade of your extension, and this is the same tool that you use to deploy your extension and run the extension directly while you are developing. The way Zeppelin works is basically you use your design tools like XD, Figma, or Sketch, and then you import your project into Zeppelin, and using Zeppelin extension you can translate that design into code. So we are writing one of those extensions for our metadata format. So what will happen is this is a demo project in XD, just one rectangle and one text which looks like a button, and we'll try to export this. So they have a plugin called Zeppelin for XD. So using this plugin you can export this project into the Zeppelin application. So we use the same project and we'll run our extension and see how we can generate this metadata file. So I exported the project, and this is the project in Zeppelin application. Now we will run our plugin and see how we can export this rectangle and a text into our metadata format and generate QML from it. So this is our small little extension that we created using the Zem tool. This is a Node.js application. You have package.json file, which tells about your dependencies and some information about this extension, which will be displayed when your extension is loaded in the Zeppelin application. So the part that you should focus on is the start script, which is Zem start. What it does, it will build your extension, it will deploy in the application, and you can there is a process to load your local extensions. You can find it in the documentation very easily. So every time we make a change in our code, the start script will every time we save the file, it will rebuild the extension and redeploy, and we can work seamlessly making changes and seeing like what effect does it have. Let's look at the code, very small code that I have written. So the way Zeppelin works is like you move your selection over the layers, and the code that this layer will generate is usually shown on the right hand side of the right pane of the application. So this is the function that the Zeppelin application will call every time the selection will change, the function layer. So it sends you the context object and the selected layer object. Context is just about the document information and all that stuff. So in this function, what I do is, irrespective of which layer we select, we walk up that layer and try to find the top layer, and from that top layer we try to generate the metadata for this whole tree. So this is what the first API at line number 14 is doing, top layer. So it will find the top layer, and then I call my small little function, helper function of dump layer tree, and I also pass which export type this layer should have, and then I just create this, and this dump layer tree give me the whole array of artboards, and I add some dummy plugin info object and document info object and artboards packet and send it back to the plugin, and then plugin and display this data on the right side of the application. Let's look at the helper method dump layer tree. So we send a layer to this method, and it will walk down its children and create for each child the layer object. I also pass the export type and the index for the stacking order, and you can see that I'm returning the layer object at line number 158. So it's a layer name, index, layer position, and the metadata associated with that layer. Let's look at the layer metadata object. Here, for each layer, we generate the metadata object. So first is the QML ID, and we call this sanitized QML ID. So we pass it the layer name, and we make sure there are no characters inside this name that are not valid to be a QML ID. So we make sure and to remove the extra spaces and invalid characters and all that stuff. Then we use the source ID as the unique identifier. Luckily, Zeppelin assigns a unique ID already to each layer, so we use the same one. Then I'm looking if the layer is a shape, then I'm assigning the QML type rectangle to this. And we'll see that when we import this layer, that this is the same type that will be assigned in the QML. And then I also parse the color, and if it's the text layer, the text details are also part of this metadata. Let's build our plugin now. So I just ran npm run start command, and it will run my start script, the Zen start. What it will do is like build the plugin, deploy it, and run it in the Zeppelin application. And we'll see in the Zeppelin application, whenever we move selection, it will dump the whole layer tree into the JSON format which we have programmed. Here in the Zeppelin application, I have selected the rectangle, and irrespective of if I select rectangle or text, it will dump the whole layer tree. And on the right side of the application, you can see my QtBridge, that was the extension name, and this is the data which the layer function has returned. So we have our plugin object, project, and our document info. And artboards, this is the artboards that we built, and button is the topmost layer here, and all the properties x, y, height, and metadata. Then it has two children, background, and label. And you can see a rectangle is assigned to the type name, and I expect a rectangle to be generated when we import the QML in Qt Design Studio. The color values are also formatted into ARGB format. And with the label, we are also exporting the text detail like font family, what is the text content, text colors, and everything. So we'll copy this stuff, we'll save it as a .metadata file, and we'll try to import this into Qt Design Studio. In the Qt Design Studio, we'll open the same project, and we'll select the file that we saved as .metadata and try to import this file. And let's import this. And if you see, like, there's nothing much to import, so it's a quite quick process and no warnings or nothing, and it will generate button.ui.qml. That was our component. So if you look at the code, like we have specified in our JSON format that we want a rectangle, and we had this text details for a layer, so the text object is created, and the color that we assigned for the rectangle is also there, and all the text properties, text, and pixel size, alignment, style name, and everything is here. And if you can see, the text is also the QSTR macro is also added to the text. You can change the macro that you want to use from the quick options in the preferences. Let's head to the form editor, and this is the rendering that we expected. Thank you for your time. I hope it was informative. You can find the metadata format details on blogs.qt.io. I'll update the blog every now and then when we have some new feature or we have any update in the properties. Feel free to reach the Qt Design Studio team for any questions or suggestions. We'll be happy to revert back.